This project is a high-performance log ingestion and query service built with TypeScript, Fastify, and PostgreSQL. The main goal is to ingest logs reliably under constrained resources while keeping search and aggregation available. I will briefly outline the project requirements, and then we will begin explaining them gradually. Functional concerns. We have ingestion, querying retention, and log entry schema. Timestamp, level, service name, message string, and flat attributes key value pairs. And API contract, we have 4 endpoints: get health, post logs, get logs, and get logs aggregate. And this is the performance target, as we see. System constraints, as we see here. Schema, index design, SQL injection prevention. This is evaluation criteria. Correctness under the load. Mintable TypeScript code. Optional features. Authentication. This is optional. Talk about the architecture of our application. The application uses a layered architecture. A client sends an HTTP request to Fastify. Fastify routes that request handler. Then the service layer applies business rule, and the repository layer communicate with PostgreSQL. Why did I spread the layers? Someone asked me. I will answer. I separate these responsibilities to keep each layer focused. Route handlers deal with HTTP requests and response. Service handle validation and business logic. Repositories contain SQL and database-specific code. This separation makes the code easier to test, maintain, and extend. Let's show you this case of the application. For ingestion, valid logs do not go directly from HTTP handler to the database. They enter write coordinator, which combines request into bounded batch. The batch is written using PostgreSQL binary copy through detected writer connection. This reduces the database overhead and protects the application from unbounded memory growth during traffic. Query parameters are parsed and validated first. Then the repository builds parameterized SQL pagination. Use timestamp and ID key set pagination, not offset, so the large pages remain efficient. JSON point. This is an important point to understand it. Attribute equality follows the API contract as string compression. The query use JSON containment as a gen index candidate filter than uses for the final exact string conversion. Okay, the next step is ingestion code path. As we have a class log service, logs are validated before they enter the right queue, and the logs are returned with their original indexes. Valid logs enter a bounded coordinator, which applies back pressure and coalesces requests into larger copy batches. Then, the PostgreSQL binary copy is used instead of insert statement per log. The serializer streams be allocated binary chunks, receiving UTF-8, JSON B encoding, and PostgreSQL timestamp microsecond. And the trade-off: when writer avoid concurrent copy operations on the same writer connection, it improves correctness and predictability while the read pool remains available for queries. The last thing is live demo. And the first of this stage, I will send one real log to the API. The server is running, and I want to go to bash, and now I'm sending one real log to the API. The response shows expected equals 1. This means the logs passed validation and was prepared successfully. The rejected array is empty, so there were no invalid fields. Now I query the same log by service and attribute the API return. The API returns the matching log and next cursor when more page exists. Attribute filtering supports JSON B values while receiving the API string conversation contract. Now for aggregate function. This endpoint groups log into 1 minute time packets. Empty packets can be omitted, and the output is ordered by packet start time. For performance analysis, I can use explain analysis on important SQL queries. This shows whether Postgres uses index, how many rows it reads, and where time is spent. I use this to distinguish between slow SQL missing index and database resources contention. The project validates malformed input and returns clear error response. Attention deletes all logs gradually in batches to avoid log database logs. Authentication is optional and disabled by default, so the required log generator work with zero configuration. The project includes TypeScript, checks unit test, contract test, Docker Compose, and CI. Thanks you for watching.